Hi and welcome to this episode of On Maths. Today we're looking at the Edexcel November 2016 Paper 1 prediction. Enjoy! Hi, I'm Chris Gilpin and welcome to this prediction video. So, the whole paper is on the website on onmaths.com. You can go onto the website, try the answers, it marks it for you, and it does what we're about to do, shows you what grade you are at, and shows you what grade the paper's at. So it marks it itself, it gives you a grade at the end. It's great for practice, so please feel free to log on and have a go at that. The link is in the description. If you enjoy this video, please click like or subscribe, and that inspires me to make more. So, without further ado, let's get started. Okay, so I'll pause the video now if you want to have a go. Otherwise, let's get started. So, reading the question, we've got 20 biscuits and Fred wants 30. So the first step is to try and figure out how I'm going to get from 20 to 30. Now, I could add 10, but proportion doesn't work that way. We're either going to times or divide. Now, it doesn't seem like there's a nice easy number to get straight there. Well, those of you maybe out there thinking, well, you can times it by 1.5, and that's true. We can get that number by doing 30 divided by 20, and that's 1.5. However, if you don't know that it's going to be 1.5, you can actually do it in two steps. First thing I could do is divide it by 2, and that will get me 10. Then I can times it by 3, which will give me 30. So all I need to do is divide by 2, then times by 3. And I need to do that to each of these ingredients. So first of all, I'm going to be looking at the flour, which is this one here. And so I want to be doing 200 divided by 2, and then times by 3. Now I'm going to show the examiner that it's the flour I'm doing. 200 divided by 2 is 100, times by 3 is 300. So answer is going to be 300. So let's do the butter next. Okay, so let's have a look at the butter. This is 140, so 140 divided by 2 times by 3. Now half of 140 is going to be 70, and then times by 3, well 3 times 7 is 21, so 3 times 70 is 210. Okay, let's do the sugar next. Okay, so what's the sugar? The sugar is 100 grams, so it's 100 divided by 2 times by 3. And 100 divided by 2 is 50, times by 3 is 150, so it's going to be 150 grams. And lastly, the eggs. Okay, so let's have a look at the eggs. There's only 2 of them. Okay, so it's going to be 2 divided by 2 times by 3. 2 divided by 2 is 1, times by 3 is just 3. So we've got 3 eggs. Now, sometimes you do need to write the units, but these actually already give the units, so we don't need to worry about that. Okay, let's move on to the next question. So the next question says that he only has 1 kilogram of self-raising flour, but enough of all the other ingredients. So we assume he's got enough butter, sugar and eggs. What's the maximum amount of biscuits that James can make? Okay, so for this question, what we need to be thinking about is, first of all, what is 1 kilogram in grams? Because all of these ones are in grams, apart from the eggs, obviously. So 1 kilogram equals, kilo means 1,000, so it equals 1,000 grams. Okay, Now we have to look at how much self-raising flour we've got. So we've got 200 grams of self-raising flour. So for one batch of ingredients, for one of these at the top, okay, for this we need 200. So we'll need 200 for one. For two batches of those ingredients, we need 400. For three batches, we need 600. For four batches, we need 800. And then for five batches, we need 1,000. And actually that is how much we've got. Okay, so how many biscuits does that 200 grams make? Well, it tells us here 20 biscuits, and we can do 5 lots of that recipe. So the answer is going to be 5 times that the 20. Okay, so 5 times 20 is 100. Now it could, I think the ones on the website are not that easy. So when you just do the times table, you stop when you get the biggest number that doesn't go above 1,000. And then whatever number you get there, you times by whatever the amount of biscuits the ingredients for. Okay, so if you want to pause the video now and have a go, otherwise let's get started. So a nice scatter graph question. If I try and zoom in, would help. Okay, so first thing I always do is I always draw a line of best fit. So this will go down like that. And it doesn't matter if you're too precise, or too. It doesn't matter if you're not very precise. They're very lenient over line of best fits normally. Okay, so let's have a look. Describe the type of relationship between maths and history results. Okay, so it is clearly going to be negative. And the reason I know that is it goes downwards. So it goes downwards from left to right, therefore it's negative. So as maths results increase, history results decrease. There we go. Okay, let's have a look at the next question. So another student got 30 on their history test. Now always be careful to read which one they got 30 on. Okay, it's very easy just to assume it's the one at the bottom. Okay, but it's actually the history test. Estimate what they got on their maths test. So when it says estimate, they are willing to give a bit of leeway because everyone's probably got a different line of best fit. So let's just check 30. So let's go across from 30. Okay, and I go across until I hit my line of best fit. As soon as I hit my line of best fit, I then go downward. Let's try and get a bit better. There we go. And I think that's pretty much 30, maybe slightly more than 30, but I'm going to go for 30 for that. And there we go. Okay, so if you want to pause the video now and have a go, otherwise let's get going. So we have James has just received an electric bill, below is part of it. So his new reading is 3,900 and his old reading is 3,710. The important part is this price per unit. That's how much he gets charged per unit. So work out how much James needs to pay for his bill. So you only get charged with electric bills for the amount that you've actually used. So he started the month off on 3,710 and then the little ticker adds one on every unit he uses until at the end of the month or quarter or whatever this is done over, it then goes up to 3,900. So we first of all need to work out, well, how many units did he use? So we do 3,900 and we take away 3,710. This is non-calculator, so we have to do this without a calculator. So 0 take away 0 is going to be 0. Now you can't do 0 take away 1, so you're going to have to nick 1 off that 9, so that 9 turns into an 8. We carry 1 over, so we do 10 take away 1, which is 9. Okay, 8 take away 7, which is 1, and then 3 take away 3 is nothing. So he's used 190 units. Next thing we've got to do is work out, well, okay, he's used 190 units. How much money is that? Well, it's 9 pence a unit. So I could do this a number of different ways, but I'm going to use multiplication grid. Why not? Okay, and we'll need 3. So we're going to do 9, because that's the price per unit, times 190. And that's just 0, so we don't have to worry about that last box, because 0 times 9 is 0. So 9 times 9 is 81. So 9 times 90 is 810. 9 times 100 is 900. Okay, and then we need to add those together. So 900 plus 810 is going to be 9 plus 8 is 17. So that's 1,710 pence. So in pounds, the decimal point is going to go between the 7 and the 1. So it's going to be £17 and 10 pence. Thank you very much. Okay, so if you want to pause the video, do it now. Otherwise, let's get started. So I'm just going to zoom in on this so we can see it a little bit clearer. So the first one says expand. That means get rid of the brackets. Now I always do this with smiles and rainbows. You might have a different method. The smile tells us that we want to do 10 times the 3x. The rainbow tells us we've got to do 10 times the positive 2. So let's do the 10 times the 3x first. 10 times 3x, so 10 times 3 first is 30. And then we've just got that x. Then we're going to do the 10 times the positive 2, which is plus 20. That's going to be our answer. So 30x plus 20. Okay, this next one's harder because there's 2 sets of brackets. The first bit's easy, 10 times the 3x, 10 times the positive 2. Second bit is a bit of a gotcha. This number here outside the bracket is not a 5. It's a minus 5, and you have to treat it as a negative 5. So it's minus 5 times 4x, then minus 5, and again, a little bit of a gotcha here. This is not a 7, it's a minus 7. So it's minus 5 times negative 7. So, first thing we need to do is do the first set of brackets. So 10 times 3x is going to be 30x. And 10 times positive 2 is going to be 20. Now, minus 5 times positive 4x. A negative times a positive, it's always a negative. 5 times 4 is 20. And we've got that x. Now the next one, minus 5 times negative 7, is going to be 2 negatives that make a positive. So it's going to be a plus, and 5 times 7 is 35. Now we've got to be careful here because it says expand and simplify. So I'm going to have to look at my like terms. We've got a 30x and a negative 20x. And we have, as numbers, we've got a plus 20 and a plus 35. So when I do 30x take away 10x, I'm going to get, take away 20x, I'm going to get 10x. And when I do 20 plus 35, I'm going to get 55. That's our answer. Okay, so the next one is expand and simplify quadratic, so double set of brackets. Now we can do smiles and rainbows still for this one. So if I wanted to, I could do a smile and a rainbow for the 11x, and a smile and a rainbow for the minus 2. That would work. It would be absolutely fine. What I could also do is something called FOIL, which tells us to do the first, outside, inside, and then last. Now the two first terms are going to be 11x and x. So 11x times x is going to be 11x squared. Now outside is the 11x and the 3 and the positive 3. So 11x times 3 is going to be 33x. The inside ones is a minus 2 and the x. So negative 2 times x is going to be negative 2x. And the last is the minus 2 and the 3. So negative times a positive is going to be a negative. And 2 times 3 is 6. Now normally, not always, but normally you'll be able to collect like terms with these two here. These are the ones that will collect together, okay? So look out for this. So our first answer is going to be just 11x squared. There's no other x squareds there for it to collect with. But we're going to do 33x take away 2x. So it's going to be plus 31x. Okay. And then we've just got the negative 6. And you can't make that answer any simpler. Now on the website you just do an @2 for the squared. Okay, now whenever we come to the word factorize, okay, we're always going to be putting it into brackets. Now looking at this looks like it's going to be a linear set of brackets, so just one set of brackets. And I always put the brackets out first. Okay, first thing I look at is the numbers. So 30 and 20, the biggest number in both those times table, the highest common factor of those is going to be 10. And then I look at the letters. We've got an a squared there, so that's got two lots of a times together, but this only has one lot of a. So the maximum I can divide out is going to be just a. Now let's do it. What I want to be thinking about when I do the brackets, the inside of the brackets, is what do I times 10a by to get to 30a squared? Well, let's do the number first. What do I times 10 by to get to 30? Well, I'm going to times it by 3. And what do I times a by to get to a squared? Well, it's just going to be a. Then I ask myself the same question in the next one. What do I times 10 by to get to 20? It's going to be 2. And what do I times a by to get to a? Well, nothing. Well, technically 1. But when I times the 2 by the 10a, I'll get 20a. And you can actually check your answer by doing smiles and rainbows on this. 10a times 3a is 30a squared. 10a times positive 2 is going to be 20a, so it works. So answer is going to be 10a brackets 3a plus 2. Okay, let's look at the last one. Let's scroll down. Okay. This time we've got a quadratic, and the reason I know that is we've got a y squared, we've got a y term, and we've got a number term at the end. Okay, so the only difference here is I need two sets of brackets. Now the first two numbers or expressions in both the brackets is going to give us the y squared. So that's going to be y and y. Now to work out what these two numbers are going to be, I need two numbers that times together to make 28 and add together to make negative 11. Now clearly to make negative 11 we're going to have a negative there somewhere, but the only way we can have a negative to get that minus 11, but when we times them we get a positive, is if they're both negative. Now I'm just thinking, right, numbers that make they're going to 28, so I could just do 28 here. So 1 times 28, so negative 1 times negative 28 is going to be minus 29, so that's not really that close. Negative 2 times negative 14, and that's going to be negative 16, so we're getting closer. What about negative 4 times negative 7? So we think 4 times 7 is 28, and negative 4 plus negative 7 is going to be negative 11. So the answer is going to be y minus 4, y minus 7. Now there are a few different methods to each of these questions, so if you've got a perfect method that you like using, stick with it and that's absolutely fine. Okay, pause the video now if you want to have a go before we get started, otherwise let's get going. So we are using indices here with letters, and we've just got to remember the rules. And the rule for this one is if they have the same base, and the base is the a, so it's the thing that you're doing the power to, and you're timesing them, then we just add the powers. If you think about it, this is going to be a times a times a times a times a times a, 6 times, and this is going to be a times a times a blah 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 10 times. So altogether we are doing a to the power of 6 plus the 10. Okay, and so that's a to the power of 16. Okay, this next one, this set of rules here, this bracket means that we're doing this bracket to the power of 10. So we're doing m to the power of 5 10 times. Okay, so the rule is if you've got a bracket, you times them. So the rule for this one will be, the power will be 5 times 10. Okay, so it's m to the power of 50. And we've got quite a complicated one here, where we've got numbers, letters, all sorts in a fraction. Now fractions in maths just mean divide. So we're going to do the numbers first. So we're going to do the 72 and the 12. 72 divided by 12 is going to be 6. Okay, so just do your 12 times table until you get to 72, and it's 6. So next we're going to do the r, and it's just a little r there. Okay, at the top we have r to the power of 1, and at the bottom we have r to the power of 3. Now the rule is, when you're timesing you add them, but when you are dividing, which we are here, you take them away. So it's r to the power of 1 minus 3. Now 1 take away 3 is going to be minus 2. So it's r to the power of minus 2. Now the s's we do the same as we did the r's. So we've got s to the power of 10 and s to the power of 7. So it's s to the power of 10 divided by s to the power of 7. This seems a bit easier. So we're doing s to the power of 10 minus 7. So it's s to the power of 3. So we're going to have s to the power of 3. And you'd write your answer as 6 r to the power of minus 2 s to the power of 3. Now the important thing you realise in this question is to do everything individually. So do the numbers and each of the letters separately, and you should be fine. Okay, if you want to pause the video now, please feel free, otherwise let's get started. So these types of question, there will be a transformation, and what we've got to do is figure out what transformation it is. Now be careful here, it says single transformation, so you might be able to get there by multiple transformations, but you've got to pick one. So the first thing I do is think, well, has it got any bigger? No, they're exactly the same size. So it's not going to be an enlargement if it doesn't get any bigger or smaller. So it's not an enlargement. Then I think, well, has it flipped around at all? And if it hasn't flipped around at all, then it's not a rotation. And is this a mirror image of this? Well, no, it's exactly the same image, it's just moved. If that's the case, if it's exactly the same image and it's just moved, it's called a translation. And that's all you have to do for the first mark. Now to get the second mark, you've got to figure out how it's translated. So always make sure that you know what letter you're starting at. And here it says we're starting at A and we're going to B. So pick a point on A. I always pick the top point, but it doesn't matter. And what you need to do is count how many times you jump to get to B, and we want to pick the same point on B, the one at the top. Okay, so I'm going to go left to right first, so I have to go 1, 2 left, and then 1, 2, 3, 4 jumps up. Now I can actually write that in what we call vector form. Now vector form is just a set of brackets, and at the top it's how far right you have to go, and and at the bottom it's how far up you have to go. Now we had to go 4 up, so the one at the bottom is going to be 4, and we have to go minus 2 minus 2 right, because we've gone left. Now it's not always necessary, in fact very few times it's necessary to do it in vector form, in column vector form, but if you are asked, you know how to do it. Okay, so if you want to have a go at this, pause the video now, otherwise let's get started. So, we've got quite an advanced problem here. So, the first thing to highlight is the fact that this is a square, and that the M is a midpoint. Okay, and I normally start these questions just writing down bits that I know. So I know that this one is going to be 28x, because it's a square, so it's going to be the same as this one. What else do I know? Well, if the bottom one is 28x, and this bit here is x, then this top bit's going to be 27x. Now, if this M is the midpoint, and it's 28x tall, then it's going to be 14x on top, and 14x at the bottom. Okay, I think we're done. Now, instead of working out the area of the triangle, what I'm going to do instead is work out the area of these triangles here. So that one, this one, and this one. And then I'm going to work out the area of the square in total, and I'm just going to take them away. So sometimes you want to work out the bits you don't want and take it away from the total. So I'm going to write down area of square first. Okay, and I know I'm going to do 28, so I'll underline that. So I'm going to do 28x times 28x. Okay, let's do some working out then. So I want to do 28 times 28. Well, I'm going to do it up here. I've got a bit of space here. Okay. So 28, so 20 and 8. Don't worry about the x because we'll deal with those later. Times 28. So 8 times 8 is 64. 8 times 2 is 16. But 8 times 20 would be a 0 at the end. This is the same calculation. And then 2 times 2 is 4, and there's 2 zeros. So we need to add those up. So 400 plus 160 plus 160 plus 64. Okay, so that last column's going to be a 4. That's going to be 18, so carry the 1. 4, 5, 6, 7. So it's 784. Now we're going to do the x's now. X times x is x squared. So that's a lot. Right. Now we're going to go through bit by bit and work out the area of the triangles. Okay, what I like to do normally is just label them just so I can have some sanity on it. So we're going to have triangle A first. Okay, triangle A. Now the area of triangle, okay, let's say area equals half times base times height. So I'm going to do 14 times 1 times a half. Or what I could do, which would be a bit easier, is if I just halve the 14 and make it 7, then it just makes it a little bit easier. So 7x times x, which is 7x squared. I'm going to do that for all of them. So I'm going to do triangle B next. Okay, so this time I'm going to halve, well, why not halve this one, because I know what that's going to be. So I'm going to do, so area equals, and I'm halving the 28x, so it's going to be 14x times 14x. Now I know 14 times 14 is 196. You should know your square numbers up to 15. Okay, and it's x times x again, so it's x squared. Now let's do triangle C. Okay, now the triangle C I think is going to be the hardest one. Okay, let's look at which one I'm going to halve. And we might halve that one. Oh, it's green all of a sudden. Right, so it's going to be 14x times 27x. So the area 14x times 27x. Now we'll do the same thing again as I did before. I'll do it underneath, why not? Ooh. Okay, so I'm going to do 14, so 10 and 4 times 27. Okay, so 4 times 7 is 28. 7 times 10 is 70. 4 times 20 is 80. And 20 times 10 is 200. So let's add them up. Okay, so the last one's going to be 8. It's going to be 15, 16, 17. And then add the 3. So that's going to be 378x squared. Okay, so we have the area of the square. Ooh, don't want to do that. So that should be 784x squared. We have the area of the square, which is here. Okay, and we have the area of the triangles here. So these are the area of the triangles. Now the triangle in the middle is the only bit remaining if we take away triangle A, B and C. So we want to take them away. So we're doing 784 and we're going to take away all the others added together. So let's add those together first. Might be a sensible thing to do. So 378, I'm going to ignore the x's, 196, okay, and we're going to add these together. Okay, so 8 plus 6 is 14, 14 plus 7 is going to be 21, 7 plus 9 is 16, plus the 2 is 18, and 3 plus 1 is 4, plus the 1 is 5. So 581 is the total. Oh, I'm not doing very well in this. 581, let's write that again. 581 is the total of our triangles. So we want to take away 581. Okay, from the area of the square. So don't forget that this is the area of the square. Okay, and this is the area of the triangles we don't want. So 4 take away 1 is 3, 8 take away 8 is 0, 7 take away 5 is 2. So the answer is going to be 203x squared. Okay, pause the video now if you want to have a go. Otherwise, let's get started. So, first thing in this question is we realise we've got a probability table, and the blue is 0.5 chance of happening, the red is 0.1 chance of happening, the white is 0.1 chance of happening, and the yellow is missing. So chances are we're going to have to work out the yellow soon. Okay, but we don't at the moment because it says there's 600 counters in the box. So if there's 600 counters in the box and there's a 0.5 chance of a blue coming up, then that means, well, 0.5 is a half chance. So for there to be a half chance, there needs to be 300 counters. Now, if we were looking for 0.1, we would just divide it by 10. Okay, if we were looking for 0.2, we would divide it by 10 and double it. Okay, simple as that. So work out the probability that the counter will be yellow. Now I know that all probabilities have to add up to 1. So the first thing I want to do is just add the probabilities that we've got together. And you don't need to do it like this, but I think it's a little bit easier. So 5, 6, 7. So we've got 0.7 so far. And we need to figure out how much more we need to add to 0.7 to get to 1. So 0.7, 0.8, 0.9, 1. So it's going to be 0.3. Okay, pause the video now if you want to have a go. Otherwise, let's get started. So with these types of question, you're either going to be asked what's wrong with the question or what's wrong with the response section. Okay, I think here is quite clear that we're looking at what's wrong with the question rather than the response section. Let's have a look. Response section, let's check that there's no overlaps or gaps. So we have 0, we have more than 0 but less than £10, equal or more than £10 but less than £20, equal or more than £20. So there's no box that I can tick twice, or that I could, that I have an amount of money that I can't tick the box. However, looking at the question, how much money do you spend on crisps? Well, last week, this year, who knows? So the answer to this question is going to be no time frame. Now you can get the mark by saying that you don't specify, or it doesn't say when. It doesn't say last week, or it doesn't say last year. But the reason I say no time frame is it's what's going to be in the mark scheme, so you'll definitely get the right answer. Okay, if you want to pause the video now, please do so. Otherwise, let's get started. So let's go through the question and let's make sure we understand it. So the tiles that she buys, the packs of tiles it will cover 4 meters squared. She gets 25% off. The tiles are marked at £25.60 without her discount, and she has £100 to spend. And we've obviously got a trapezium here, and this is A, this is B, then this is the height here. And it's on its sides to make things a little bit more complicated. So we'll first of all look at A and B. The first thing you do with the trapezium, we can write down the formula. Area equals half A plus B H. This bit here is basically working out the average of A and B. So we can just do that in two ways. What number is halfway between 2.9 and 1.1? Okay, and a lot of you will be able to work that out. But let's follow the formula. So half, and we're doing 2.9 plus 1.1, and then we're timesing it by 10.5. We're doing half. 2.9 times 1.1 is going to, 2.9 plus 0.1 is going to be 3, so 3 plus 1 is 4, times 10.5, and then half of 4 is 2, times 10.5, which is going to equal, 2 times 10 is 20, 2 times a half is 1, so it's going to be 21. So there's 21 meters squared of floor to cover. Okay, so we know how much floor there is to cover, which is this one here. Okay. Now the next bit we've got to do is work out, well, how much does she pay? So in pence, and we can do this in pence, so I'm going to do price, show the examiner what I'm doing, and in pence it's 2,560, and we're going to halve that, so I'm going to divide that by 2, so 560, so 500 divided by 2 is 250, 60 divided by 2 is 30, so that's going to be 280, and then half of 2 is 1, and we're going to divide it by 2 again, and that this time half of 1,200 is going to be 600, and half of 80 is going to be 40. We could have done that a different way. I can show you a different way you could do that. So you could have said 4s into 2560. 4s into 2 don't go, so carry the 2 across. 4s into 25, it goes 6, carry the 1. 4s into 16 go 4, and then 4s into 0 go. So it's the same answer. So she's going to get £6.40 or 640 pence off, but that's not how much she pays because she gets that money off. So we could do this in one of two ways. We could add together these two values, not that one, these two here. Let's show you here, these two here. So that 1,280 is a half of it, and 640 is a quarter, and a half plus a quarter is 3/4. Or I could just take away 640 from 2,560. So 2,560, take away the quarter, okay, and 0 take away 0 is 0, 6 take away 4 is 2. Can't do that, so we're going to have to nick one off the 2. 15 take away 6 is 9. 1 take away nothing is 1. So she's going to pay 1,920. So that's how much money she's going to pay. And that's in pence. Okay, so we've got somewhere. Now she needs 21 meters squared. And each time she buys 4. So packets, I could say here, packs. We'll work out how many packs she needs. So if she buys 1 pack, it's 4. If she buys 2 packs, it's 8. 3 packs would be 12. 4 packs would be 16. 5 packs would be 20. Now she was almost there. Remember, she needs 21, but she'll need to buy another pack because I don't like you taking some out of a pack. So she needs to buy 6 packs. Okay, so 6 packs. Okay, so she needs to buy 6 packs, and she's paying 1,920 pence for each pack. So let's say total cost. So she's buying 6 packs, and it's priced at £19.20 a pack. Okay, so I'm going to do my grids. So we're going to have 6, and we have quite a long grid. Okay, so we're doing 6 times 1,920. Don't need that last one. So 6 times 1,000 is 6,000. 6 times 9 is going to be 54. And the 2 zeros at the end of the 900. And 6 times 2 is 12, with the 0 at the end of the 20. So we need to add these up. So 0 plus 0 plus 0 is nothing. Then we've got 2, then we've got 5, then we've got 11. So the cost, the total cost is going to be this number here. But we're still not done yet. She says that she's got £100, and the question is, how much more does she need? So to finish this off, okay, we need to do the amount it costs, which is this number here. Ooh. This number here, okay, and then we're going to take away the £100 or 10,000 pence that she has already got. So 0 take away 0 is 0, take away 2, this is going to be nice and easy. So £15.20. it wants it in pence, so it's going to be 1520. So quite a long question. I hope you followed. If not, just leave a comment and I'll go through back through any areas that you have difficulty. If you want to pause the video, please do so now, otherwise let's get started. So we've had a similar question to this before. We've got a shape inside another shape and we've got to find an area of a bit at the side. Well, that's not a shape that we're going to find the area of. So what we want to do is work out the area of the whole square, take away the circle, and we know that these three other ones here are going to be equal. So we're just going to divide our answer by 4. So we're going to start off by working out the area of square. Area of square first. The area of the square, well, it says it's a square, so we know that that's going to be 44 centimeters as well. So it's going to be 44 times 44. And I can just do my quick grid to do 44 times 4 times 44. There's going to be a lot of 4's involved in this. So 44 times 44. 4 times 4 is 16. That's therefore going to be 160. That's also going to be 160. And that's going to be 16 with 1, 2 zeros. When we add those together, we've got okay, so that's going to equal 6. 6 plus 6 is 12, plus 1 is 13. 6, 7, 8, 9. And we've got that 1 there. So the area of the square is going to be 1936. Okay, now we need to work out the area of the circle. So let's do that down here. Area of circle. Area of circle is pi r squared. So that's going to be pi times, the radius is the half distance. Okay, the diameter is the full distance. Well, the length of the square is going to be the diameter of the circle as well. So we halve that to make 22 centimeters. So it's going to be times 22 squared. So I'll need to do another grid. Let's do that. Let's do that underneath. Okay, so 22 times 22. 2 times 2 is 4. That's going to be 40. That's going to be 40, and that's going to be 400. Add those together. You can probably do that without the column addition. 4 plus 4 is 8. Then that 4 there, so 484. So that's going to equal 484 pi. So to work out all of the side bits, so this one, this one, this one, and this one, we take them away. So total area is going to be the square, which was 1936, take away the circle, which was 484 pi. Now without a calculator you can't work that out, but that's fine because the question says that it's going to be in terms of pi. So we need to do the total area divided by 4. That's what we want to do, because there's 4 equal chunks and we only want one of those chunks. So we need to do each of the numbers divided by 4. So I'm going to do long division for this. So we want to divide the 1936 by 4. 4's go into 1, they don't go into 1 at all, so carry the 1. 4's into 19, well I know 4 times 4 is 16, so that's going to be 4. And that's going to have 3 left over. 4's into 33, I know 4 times 8 is 32. And 4's into 16 go 4. We're going to do the same with the other one. 484, so that's going to be 1, 2, 1. So when I do it, I end up with 484 minus 121 pi. Nice and easy, maybe not. So let's put the answer in here, 484 minus 121 pi. And that's our answer. Okay, if you want to pause the video now, please feel free, otherwise let's get started. So, simple solve first, and whenever I have a solve, I always put lines down where the equal sign is. I find it a lot easier. And we are going to first of all expand the brackets, so I'm going to do smiles and rainbows on this. So we end up with 4x minus 40 equals x plus 2. Okay, now notice I've got x on both sides. Okay, now whenever I have x on both sides, I look at the x's and see which one's the smallest. Looking at those, the 1x is the smallest, so I'm going to take away the smallest, and I'm going to end up with 3x minus 40 equals 2. Then I'm going to add the 40 to both sides, okay, because at the moment that 40 is a negative 40, so I do the opposite of that, which is plus 40. I'm slightly running out of room here, so I'm going to put my answer up here. I do another set of lines. Okay, so we're going to end up with 3x on the left hand side equals, and then 2 plus 40, which is 42. Okay, then I've got this 3 here, and that's actually a times 3. So to get rid of it, I need to divide both sides by 3. So I'm going to divide the left hand side by 3 and the right hand side by 3. So leaves me with x. And now I've got to work out how many 3's in 42. Well, I know 3 times 10 is 30. And I know 3 times 4 is 12, so the answer is going to be it's going to be 14. Okay, I could put that 14 back into the equation up here and check that it works, but probably I'd do that if I had some time left in the exam. Okay, let's go on to the next one. So I'm going to do the same thing again and put my lines down. Okay, we've got a fraction here. Now, whenever we have fractions, we can't really do anything with this fraction here. Now, all that fraction means is divide the whole left-hand side by 3. So to get rid of it, we just need to times both sides by 3. And that will get rid of the fraction. The top stays the same. We don't times the top by 3. Okay, by timesing it by 3, we've got rid of the bottom, but the top stays the same. And 1 times 3 is 3. Now we've got a tricky one here. We've got a negative y. So I'm going to deal with the 11 first. So I'm going to take away 11 from both sides. And that leaves me with minus y equals 3 take away 11, which is going to be negative 8. Now something I can do here is I can times both sides by minus 1. When I times both sides by minus 1, it gets rid of any negatives. Well, it switches the signs. So if I had an 8 on the right, it would turn into a minus 8. But they're both negative, so it's just y equals 8. So my answer to that is y equals 8. Now what I could have done at this stage here is I could have added the y to both sides and then taken away the 3, and that would leave me 8 equals y, which is the same as y equals 8. It's just a matter of preference. which one you choose to do in the exam. Okay, if you want to have a go at this, pause the video now, otherwise let's get started. So, important to realise that we're looking for prime factors, but a lot of people miss out on this word here, product. Product means times, and we'll come to that in a bit. Easiest way of doing this is to do 88 and two things coming out of it. Now, we're looking for primes that we can divide 88 by. The most obvious and the easiest one is 2, and what I do is I circle the primes when I find them. Now when I halve 88 I get 44, so 44 times 2 is 88. Now the 44 is not a prime, so I can't circle that, so I can split it up again and I can get another 2 out of it, and that leaves me with 22. 22 is not a prime, I can get another 2 out of it, and it leaves me with 11, which is a prime. So the prime numbers that we've got are 2, 2, 2 and 11. But you need to write it as 2 times 2 times 2 times 11. Some people actually multiply those together, but you should get 88 if you did that. One last thing to realise is that the question says write your answer in index form. So when I've got 2 times 2 times 2, I can write that as 2 to the power of 3 times 11. So it's going to be 2 to the power of 3 times 11. Okay, if you want to pause the video now, please feel free, otherwise let's get started. Now, what I like to do with this is split my page up a little bit, and I want to tackle each bit individually. So I'm going to look at the totals first. Then I'm going to look at the boys, and then I'm going to get the answer by looking at the mean for the girls. Okay, so the totals first. Now what we need to know about the mean is that the mean equals the sum of the numbers, whatever they are, okay, because it doesn't tell us, divided by the amount of numbers, so the total amount of numbers. Okay, the mean for the total, so let's have a look at that. So we have 33 boys and 22 girls, and it says the mean for the total is 21. So the mean for the total is 21, and it says, well, we don't know what the sum is, so I'm going to call that T now, over the total amount. So 33 plus 22 is 55. So T is 21 times 55. Now I'm going to have to do a grid somewhere to work that out. Let's do that over here. So we've got 21 times 55. 1 times 5 is 5. 5 times 20 is 100. 1 times 50 is 50. And 2 times 5 is 10 with the extra 2 zeros. So looking at that, that's going to be 1155. Okay, let's work it out for the boys as well. So like before, the mean is the sum over the total amount of numbers. Okay, so the mean, it says, let's have a look, where does it say what the mean is? It says here is 19, so it's 19 for the boys. And let's do a B for the sum. I'll do a capital B because my little b's look like 6's, and it says that there are 33 boys. So B is 19 times 33. So we can do another grid. Not as pretty as the first one. We've got 19 times 33. 3 times 9 is 27. 3 times 10 is 30. 30 times 9, so 3 times 9 is 27, plus another 0, and 30 times 10 is 300. Okay, so let's just add those up. That's going to be 570. Let's do the working out for fun. So that's going to be a 7, that's going to be 12, and that's going to be 6. So the boys' total is 627. So the girls' total is going to be the total's total minus the boys' total, and I'm just squinting across. And so let's do that. 1155 minus 627. Okay, I need to nick one off that. So 15 take away 7 is 8. 4 take away 2 is 2. Nick one there. 11 take away 6 is 5. So the total is going to equal 528. Okay, so the mean, I haven't really left myself an awful lot of space here. So the mean is 528 divided by 22. And so now I've got to work out my 22 times table to get there. I know 22 times 10, so 10 lots of 22 are 220. I know that 20 lots of 22 are going to be 440. And I know that 4 lots of 22 are 88. If I add those together, that will be 8,528. So it's going to be that 20 plus the 4. So the answer is going to be 24. Now there are other ways of doing this question. What you can do is have a look at the pull of the boys and the pull of the girls from the mean. So if you assume the mean is going to be in the middle, but that sadly is the only way that I can explain without going too in depth. The questions on the website, the numbers are a lot easier to do this for. This is a worst case scenario question. Okay, if you'd like to pause the video now and have a go, otherwise let's get started. So we've got simultaneous equations here, and they're different coefficients, the x and the y's. So we need to do a step first. Now, what most people do first is they label them A and B, which is absolutely fine. So when they look back in their working out later on, they know which equation they've done what to. And looking at the x and the y's, well, the y I could make 15, but I'm going to have to times both equations. And if I look at the x, then I only need to times the top equation by 2 to get the x's the same, to get that 2 to a 4. So I'm going to do 2a first. I'm going to times everything in equation a by 2. So we've got 4x plus 10y equals 48. And it's very easy to forget one of the terms when you times them all by 2. And I'm just going to copy b down. I'm not doing anything to it. Okay, with simultaneous equations we're always working downwards. So we're looking at doing this. We're looking at these. And then we're looking at these. So we're working downwards. Now, we need to figure out what we're doing. Well, the whole target of simultaneous equations is to get rid of the x or the y. Looking at the fact we've got a 4x here and a 4x here, if we add them we'll get 8x. Well, we don't want 8x, we want 0x, we want to get rid of it. So we're going to be taking away. Now, if they are the same sign, if they're both positive or both negative, you'll always take away. If they're different signs, then you add them. Okay, that's the rule. So we're doing 2a minus equation b. Now this first bit is going to be 0, which is the whole point of doing this. But this second bit is 10y take away minus 3y. Well, that's going to be two minuses next to each other will be a plus. So that's going to equal 13y. And again with this, 48 take away minus 4, that's going to add. So that's going to be 52. And then I do my little lines down. Don't have to get very far because all I need to do here is divide both sides by 13. So y equals, well, I know 13 times 2 is 26, 26 times 2 is 52, so it's going to be 4. Now I go back to the original equation and I substitute in the 4. So 2x plus 5 times 4, and I should say here I'm doing this to equation A to remind me later on if I want to check my answer. 5 times y is going to be 5 times 4, which is 20, equals 24. And then if I put my lines down, I can take away the 20 first. So that's 2x equals 4. And then just finish it off by dividing it by 2. X equals 2. And I can check that with equation B. 4 times 2 is 8. 8 and then it's take away 3 times 4, which is 12. So 8 take away 12 equals minus 4. So we know it's right. So x equals 2 and y equals 4. Okay, if you'd like to pause the video, please feel free. I'm going to also zoom in as well. And I'll just scroll down and you can pause it at the different sections. That's the question there. Okay, let's get started. So, nice cumulative frequency question. With cumulative frequency, cumulative means it keeps either staying the same or keeps going up. Okay, it's a running total. I think if the exam, instead of cumulative frequency there, if they said running total, I think everyone would get it right. However, it's called cumulative frequency, so they stick with it. So far, the column we're looking at when we do this is this column here. So that's what we're looking at. We're looking at adding them up each time. So the first one's going to be 8. The next one's going to be 8 plus 4, which is going to be 12. Then the next one after that is going to be 12 plus 15, so that's going to be 27. The next one after that is going to be 27 plus 22, which is going to be 49. And then the last one is going to be 49 plus 11, which is going to be 60. Okay, so we've done the first step then. And the next step is going to be to draw our cumulative frequency graph. So let's have a go at doing that. So we need the values 8, 12, 27, 49, etc. We also need to have a look at this. Now, this looks like it's going to be a midpoint because a lot of people remember frequency polygons, which you do a midpoint for. For cumulative frequency, it's always the last number on each one. Okay, so the first one is going to be plotted at 5 and it's going to be 8 high. And we could also do 0, 0, but it's already on there. So 5 and it's going to be 8 high, so it's going to be about there. Okay, the next one is going to be at 10 and it's going to be 12 high. So 10 and that's going to be 12 high, about there. The next one is going to be 15 and it's going to be 27 high. So 15, 1, 2, 3, 4, 5, 6, 7. It's about there. Okay, the next one's going to be 20 and it's going to be 49 high. So if I do 50 and go down 1, I think it's about there. Forgive me if I'm off slightly. And the last one, 60, is at 25. So 60 at 25. Now we should line these up. We should draw a nice curve for these, but actually in the exam it doesn't mind if you just join them up with straight lines. So use your ruler and just join up all the points with straight lines, and you'll always get the mark for doing this. The most important thing is that the line goes through all the points. Okay, and that's it. So it says use your graph to find an estimate for the median age of the people questioned. So we look at the side axis and it goes up to 60. We make sure that if it said 70 there, we look at where our maximum point on our graph is, which is at 60. We then halve that, and that gives us 30. And we just draw a line across from 30 and down. So across from 30 and down. I think that's about, what do we think, about 16, I think. Okay, this next question is slightly harder. It says, what age were 25% of the people questioned older than? So we need to find out, basically we need to find an upper quartile for this. And it's the upper quartile, not the lower quartile, because it's the age at which 25% of people are older than. So a quarter of the people are older than it. So to do this, we find out what is halfway between 30 and 60. One way you can do it is just half 30, which is 15, and then add it on. It will be 45. So it's about here. And we just do the same thing as we did before. So we do a line across from 45 and a line down, and I think that's 18 or 19. Normally they allow you a little bit of leeway on this, okay, whether it's 18, 19 or 20, as long as you show on your graph how you've done it, and that's the important point. So if you'd like to have a go at this question, pause the video, otherwise let's get started. An important point to realise with this question straight away is that yes, we have A, and AB describes the line, but we're given A and we're given the midpoint. Okay, so we're going to have, let's just draw a line and let's put it into 3 sections. Okay. We've got coordinate A, we've got coordinate B, and we've got our midpoint. And we're going to do it for the X, the Y, and the Z coordinates. So at point A, it starts off at 3, and the midpoint then is -4. So what we need to do is figure out how we get from 3 to -4, and we're going to take away 7. So to get to B, we just need to take away another 7. So -4 take away 7 is going to be -11. And we're just going to repeat this. I'm just going to try and tidy up that 11. I'm going to repeat this for all the other coordinates. So that's 4, and that's 6, the Y. So that's a +2. So we're going to add 2 again, and that's going to give us 8. So we've got 12, and we've got 14. So it's another +2. +2 again gives us 16. So our answer is -11, 8, 16 will be the coordinates of B. Okay, if you want to pause the video now and have a go, otherwise let's get started. So we've got 2 cuboids, A and B. A is obviously bigger than B, but if we have a look at the length here, the 4 centimeters and the 8 centimeters, there's clearly a scale factor, and it says that they are similar cuboids. So when they're similar, it means there will be a scale factor. Now the gotcha for this question is to not realise that length, volume and area scale factors are not the same. The length scale factor for this question, so length scale factor, can be found by asking the question, how do you get from B to A? And we'll work in that direction from B to A, because on question 1 it's asking us for what cuboid A volume is. So the length scale factor is 8 divided by 4, which gives us 2. Now when we're working with the area scale factor, it's going to be timesing each dimension by 2. Now an area is 2-dimensional, so it's 2 times 2. So the area scale factor is 2 squared, which is 4. The volume scale factor is again timesing by 2 in each dimension. it's 3 dimensions, so it's timesing by 2 3 times, or doing 2 cubed, which is going to be 8. So when we're looking at answering this question, we're thinking, right, cuboid B is going to be 90, so cuboid B is 90. What is cuboid A going to be? So it's obviously going to be bigger, so what I want to do is 90 times the volume scale factor, which is 8. Now 9 times 8 is 72, so 90 times 8 is 720. Now for the next question, we're working backwards. It's going to give us cuboid A's total surface area, which is 200, and we'll work out what cuboid B is. Now, if we times the 200 by something, by a number bigger than 1, we're going to get a bigger number, and that doesn't make sense because cuboid B is smaller. So, because we're working backwards, instead of timesing it by the scale factor, we're going to divide. And because it's area, we look at the area scale factor. If we have a look, the area scale factor, it says, is 4. So we're going to divide by 4. Now to divide by 4, you halve it and then halve it again, which gives us 50. So that would be 50 centimeters squared. Okay, if you'd like to pause the video now, have a go. Otherwise, let's get started. So there are 7 students in total, 4 boys and 3 girls. Now the question talks about a whole load of stuff, but the most important thing is that 2 people are randomly picked and everyone can be picked, and that the same person can be picked twice. Now something to be careful of is when a question says, when it asks you to work out the probability of 2 things happening. Okay. Now the question says that we're looking at the probability they will be different genders. Okay, that's the important thing. Now whenever it asks you the probability of something, never think of it that way. Always think about it as something and something else. Now that's something and something else. Well, different genders. So the first one will be a boy and the second one will be a girl. Or we could have a girl and then a boy. So those are the 2 outcomes that would happen for us to have 2 chosen students that were different genders. So we're going to change that into maths. So the probability of a boy being picked is going to be 4, because there's 4 boys, over 7, because there's 7 students in total. Now here's a key word for probability, the word and. The word and in probability actually means times. So we times that for the probability of a girl being picked. So it's going to be 3 girls over 7, because all people can be picked twice. Let's work that out. So that's going to be timesing the tops, which is going to be 12, timesing the bottoms, which is going to be 49. Now the other key word in probability is the word or. The word or means plus. So we're going to plus. Now we're going to do the same thing again. Girls is going to be 3 over 7. And boys is going to be 4 over 7. Which again equals 12 over 49. So we've got our 2 values here. So we've got these 2, but we need to add them together. So I'm going to rewrite that. I'll do 12 over 49 plus 12 over 49. And the rule for adding fractions is you add the tops, so it's going to be 24 over 49. Now, if possible, we can cancel that down. I don't think there's anything we can cancel that with, because 7 goes into 49, but 7 doesn't go into 24. I don't think there's any other values. So we're going to write that as our answer, 24 over 49. Now, some of you might be saying, well, why didn't you just double this one? You could absolutely double this one, because we knew this one would be the same. But if it was conditional probability, you've just got to be a bit more careful, and if there's different outcomes, you're not always going to double it, but mostly you will be. So just keep an eye on that, and actually this working out is really clear, and it didn't take that much longer. Okay, if you want to pause the video now, please do so, otherwise let's get started. So, this is an algebraic fraction question where we're asked to add two algebraic fractions. But an easy way of doing these types of questions is to figure out what you would do with just normal numbers. Now, with a third plus a quarter, you would times the left-hand side both by the 4, and you would times the right-hand side both by the 3. So you'd end up with 4 over 12 plus 3 over 12. And you'd add the tops to get 7 over 12. The same things happen with algebraic fractions. We want to times the left-hand fraction by the right-hand denominator, so by this x. And we want to times the right-hand fraction by the left-hand side's denominator. So we're going to times the first fraction by x, top and bottom. So we're going to do 11 over 10 plus x. And we're going to times both of those. So we're going to times it by x over x. We're going to times top and bottom by the denominator of the second fraction. Now be careful here. What I always ask students to do is put brackets around any expressions that have more than one term in a fraction. So let's times the tops, so that becomes 11x. And let's times the bottoms, that becomes x brackets 10 plus x. So we've got a bit more work to do with that. So the top is 11x, and the bottom becomes, well, we could expand it, so that becomes x squared plus 10x. Okay, I'm going to do the same with the right hand side. So we're doing 5 over x, which is the fraction we're given. This time we're going to times top and bottom by that 10 plus x. Okay, so the top becomes 5 times that 10 plus x. And the bottom becomes, well, it's the same as before, the x brackets 10 plus x. So times in the top, 5 times 10 is 50, plus 5x. And the bottom, well, we've already done that, is x squared plus 10x. So rewriting the fraction, we can write 11x over x squared plus 10x, plus, and we've got the 50 plus 5x over x squared plus 10x. And what we do is we add the tops, so it's 11x plus 50 plus 5x over x squared plus 10x. So looking at the top, we've got the 11x and the 5x add together. So that becomes 16x plus 50 over x squared plus 10x. So our answer is 16x plus 50 over x squared plus 10x. Now you don't need to have all of the working out. When I'm marking it, I'm looking at this bit here, that you've managed to do this bit correctly. Okay, that's what I'm looking for. Then I'm looking really for this bit here, and then obviously the answer. So as long as you've got those three things in your working out, then that's more than enough. Okay, if you want to pause the video now and have a go, otherwise let's get started. So the first thing I notice with this question is that there is a squared there. So whenever that is there, I always rewrite this as double brackets, because that reminds me what the next step's going to have to be. Okay, so we've got like a quadratic surd here. So I could use the same method I use for quadratics. Now I'm going to use FOIL for this, but if you've got a different method, that's fine. Some teachers don't like FOIL, I don't mind it. So the two first numbers are 10 and 10, so we're going to do 10 times 10, which is 100. The outside ones are the 10 and the root 13. So if that was 10 and x, we would write 10x. Now that's 10 and root 13, so we write 10 root 13. We can't simplify that anymore without a calculator. The inside ones, root 13 times 10, it's going to be the same thing, 10 root 13. You always put the number first, then the surd. And the two last ones are root 13 times root 13. Now the rule with surds is if you times a surd by itself, you'll just get the number without the square root. So root 13 times root 13 is just 13. Now when we're simplifying, we've got the number 100 and the number 13, which is going to be 113, plus, and we've got the 10 root 13 plus the 10 root 13. So if that was 10x plus 10x, we'd know it's 20x. It's the same rules with surds. 10 lots of root 13 plus another 10 lots of root 13 are 20 lots of root 13. So answering the question, A is going to be 113 because that's the number on its own, and the coefficient, the number before the root 13, is 20. If you'd like to pause the video, otherwise we are going to get started. So we've got a fraction in bracket and we've got quite a complicated indice outside. So two things to notice about this. We've got a negative and we've got a fraction. Now students traditionally seldom remember what a negative does or what a fraction does. So I'm going to just draw a bigger indice here, and then I can just do some quick notes to remind us what these mean. That negative there, okay, will flip or find the reciprocal of the number that, or the base number, the number that we are doing to the power of minus 3/4. Okay, this 4 here will find the fourth root. Okay, if it was a number 2, it'd be a square root, 3 would be a cube root, but a 4 would be the fourth root. And finally, this 3 here is just a normal power, so that will just be to the power of 3. Okay, so we're going to do the first one. Okay, we're going to do the negative first on this fraction. Now that means flip. Now if it's just the number 8, it becomes 1 over 8. Okay, because technically the number 8 is the same as 8 over 1. Okay, any number, 6, 7, 8, 9, 100, 1000, is just that number over 1. So when we flip it, it becomes 1 over that number. It's a fraction already, so all we need to do is flip it. So 256 over 81. That's dealt with the negative, but we've still got the 3/4. Okay, that's fine. That's not bad for a first step. Now, the next step is we need to find the fourth root of both the top and the bottom. Okay, so I need to find the fourth root of 256, and I need to find the fourth root of 81. Okay, and then we're still going to have to cube our answer. So, what the best way or easiest way to do is just pick some really small numbers, okay, and for the fourth root, if you end up with a semi-small number, and 256 is not a very big number, then I just go through all the low numbers and think, right, what could it be? So if it's 2 to the power of 4, is that going to be 256? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, so that's not quite big enough yet. 3 to the power of 4, so 3 times 3 is 9, times 3 is 27, times 3 is 81. Ah, there we go, that's the bottom one sorted. And then 4 to the power of 4, so it's slightly harder. Okay, 4 times 4 is 16, times 4 is 64, times 4 is 256. So normally they're quite nice with the numbers they give you. I would say that the numbers here are probably as hard as you're going to get. So that top one is 4 and that bottom one is 3. The last step is to cube the top and bottom. So it becomes 4 cubed over 3 cubed. Now I know 4 cubed is 64 and 3 cubed is 27. So as a top-heavy fraction, it's going to be 64 over 27. Now you might need to write that as a mixed number, or it might not matter on the exam. Sometimes they'll say, write your answer as a mixed number, but normally as long as you've got either a top-heavy fraction or a mixed number, then that's fine. On the website you have to leave it as a top-heavy fraction, but in the exam, as I said, they're a little bit more flexible with the way you write your answer. Try and simplify it if possible as well. If you'd like to pause the video now and have a go, otherwise let's get started. So we've got a circle theorem question here. We are given the fact that it's 170 degrees at the centre, and we're asked what it's going to be at the circumference of the circle. Now, I know that this circle theorem is the angle at the centre is twice the angle at the circumference. So therefore, if it's 170 in the middle, then it's going to be 85 at the circumference, and it's just angle at center is twice the angle at circumference. You don't lose marks for spelling, but I'm pretty sure centre is supposed to be RE, not ER. Normally with these questions, there will be multiple things that you have to do. The one that they like asking sometimes is, what this one is going to be, or they'll write a number here, and then you've got to do angles at a point first to work out what this one's going to be, and then you halve it. Okay, if you want to pause the video now and have a go, otherwise let's get started. So we've got to make y the subject of the formula, which will be y equals something. And the first thing I do with expressions in brackets, in fractions, is put brackets around them, whether I need them or not. And I will always, with these types of question, put lines down either side of the equals. Okay. Now the first thing I want to do is get rid of the fraction, and to do that I'm going to times both sides by that y minus 5. Let's just sort out the times. So we're times both sides by the denominator of the fraction, because that means all of the 10 minus 3y divided by y minus 5, so we times both sides by y minus 5 to get rid of that. So we've got x brackets y minus 5, because the x on the left hand side is being times by the y minus 5, equals, and we've just left with that 10 minus 3y. Then I need to expand the bracket, so we get xy minus 5x equals 10 minus 3y. Okay, so we want to get the y's on the same side, and everything else on the so y is on the left hand side, everything else on the right hand side. So the first thing I'm going to do is plus 5x to get the 5x on the right hand side. So we've got xy equals, and we've got 10 minus 3y plus 5x. Then we want to add 3y to get the y on the left hand side. So we've got xy plus 3y equals 10 plus 5x. I need to extend my line slightly. Didn't do them long enough. Okay, so the next thing is I've got two terms here. I've got the xy and the 3y, and they both have y in, so they're both y terms. Now I need to make it so that there's only one y, so we've got just y equals. And the way of doing that is factorizing the left hand side. So I want y on the outside of the bracket, and so we're going to have x plus 3. And if you expand that, you will get xy plus 3y. Next thing I want to do is divide both sides by that x plus 3. So we have y equals 10 plus 5x over that over that x plus 3. So our answer is 10 plus 5x over x plus 3. And that's it. Okay, if you want to pause the video now, have a go, feel free, otherwise let's get started. So, this is a vector question, and first question says find AB. Now I always think vectors are like roads. We've got to get from A to B. So if we start off at A, the route to B is there. However, we can't go directly there, so we've got to go down roads that we do know the name of. So we've got to go down this road first, and then this road, to find out what the name of road AB is. So the first thing we had to do was go backwards down the road A. So instead of just A, we say minus A, because we had to go backwards down it. Then we go the right way down road B, so just plus B. So it's minus A plus B. And that's it. Now the next question says that F is a point on AB such that AF, the ratio of AF to FB is 5 to 3. So if I imagine that there are 5 whatever the units are there and 3 whatever the units are there. So I can chop those up, and then we'd have, so there's 5 units, 1, 2, 3, 4, 5 here, and there's 1, 2, 3 here. Now it says that it wants us to find CF. Now CF is this road here. So we start at C, and then we go up. We go across to A and then up to F. Now you could do it the other way, and either way is fine. So we're going to start off by going down the road A, and then we're going to go down the road that we went down before. So the minus A plus B. Okay, because we know the name of road AB. But we don't want to go the full way. Now we've gone 5 units of the total 8 units. So we've gone 5/8 of the way. So let's just expand that bracket. So, oh, that's not going to be a plus, is it? That's going to be a minus 5/8A plus 5/8B. So we've got A, take away 5/8A, that will leave 3/8A plus 5/8B. And that's it. Okay, if you want to pause the video now and have a go, otherwise let's get going. So, with functions, it's really important to realise what we're doing, and I'm just going to briefly explain that we've got 2 points here, 5 and 9. 5 is our x and 9 is our y. Now, to get from the 5 to the 9, we do a function which they've called f of x. Okay, we're doing something to that 5 to get to that 9. Okay, now we're only interested in this question about this maximum point here. So it says that the coordinates currently are 5, 9. That's fine. But we're going to do the same function, but before we do the function, we're going to take away 2 from the x. Now, when we're taking away 2 from the x, that 5 will then become a 3. And it won't go to 9, because we know that 5 goes to 9. So what number do we then have to put in to get the x, the bit inside the brackets here, to a 5, because we know 5 goes to 9. So we've actually got to add 2 more on to the x. It will be 7 that gets to the 9. Okay, it's that simple. Now, there are different ways of learning this. Basically, anything inside the brackets here will be to do with the x coordinate, or the left and right direction, and it's the opposite of what you think. A lot of people think that if there's a minus 2 there, then it will be 3, 9. Okay, it's the other way to what you'd think. But if you think about it logically, as long as the number that you end up with in here is a 5, then it will always go to 9, unless it's a different function, which it's not. Now with this one, we're going to do the function. Okay, so we've put in the 5, okay, and we've got a 9 out. And then we've times it by 2. So we've put in 5, and we've got a 9 out, and then it's doubled. So it's going to be 18, 518. Okay, pause the video now if you want to have a go, otherwise let's get started. So, we need to write a surd fraction as just an expression, and whenever we are doing that, we are rationalizing the surd. Now, rationalizing just means getting rid of the surd from the bottom, okay? So, we're going to times top and bottom by whatever the surd is at the bottom, which is root 2. Now don't forget, we always put brackets around any numerator denominator that has more than 2 expression. Okay, that will help us for later on. So we go times both of these by root 2, because that's the surd at the bottom. So the top becomes root 2 times root 32 plus 50. And the bottom is root 2 times root 2, and we should have learned by now that any surd times by itself is just the number inside the surd, the number inside the square root. Right, let's expand those brackets at the top. Root 2 times root 32 is going to be root 64 plus 50 root 2. All of that over 2. Then the square root of 64 is 8. And then let's divide both of these things by 2, because that's the same as saying 8 over 2 plus 50 root 2 over 2. So you can break that up into 2 different fractions. 8 divided by 2 is 4, and 50 root 2's, but then half it is going to be 25 root 2's. So it's asking for a and b. Now a is the number on its own, which is 4, and b is the 25, so it's the number before the square root of 2, which is going to be 25. Okay, thank you very much for watching this video. If you enjoyed it, please click subscribe and click like on the video. As I said, all of these questions are on the website. The website updates the questions and changes them each time, so every time you have a go at it, it's a slightly different question, yet the methods that we've gone through in this video are exactly the same. We're going to have plenty more content. If you're not successful, which hopefully you will be next week, then I will be doing this again for the June resets, and as you probably know, the June resets are the last ones on the legacy. I've also got loads of videos for the new GCSE, which hopefully won't apply to you at all. Anyway, thank you very much for watching this video.